So vector valued functions. So today we'll do 3 sections. Next time we'll only do 2 sections. We're only going to do 12.4 and 12.5 next time, and that's it, right? So then we have spring break, and then you have the test. So vector valued functions. So what is a vector valued function? So in the plane, explain what it is. So in the plane, a vector valued function might look like this. So we have r. So you're supposed to put a vector symbol above the r. You don't have to put it. If you don't write it, I'll let it go. So like this. Okay. And then f of t I hat plus g of t j hat. So this would be a vector valued function. So it takes a value of t, which is a real number, and gives you a vector. That's why it's called vector valued, right? So given a value of t, it spits out a vector. In space, that sounds really cool, like outer space. Let me get a better, I thought I had a better marker. Anyone that's like really dark. Oh yeah, it's better, yeah. So that's much better. So in space, it would be very similar. We'll have f of t I hat plus g of t j hat plus h of t. Make sure this is on. It's on. It's on. Good. What would go here in this case? K hat, K hat, K hat. Oh, so as far as the extra credit on the test, by the way, I think I just gave everyone 4 points because I know Rafael had 2 and then some other people, the whole class had 2, so I just gave everyone 4, I think. So just so you know, so if you see your grade, like, why is my grade so high? I just gave everyone some extra points. So, and since this is the second test, I usually don't mess up after the first test. We can start doing double points if you want. So, yeah, we'll just keep raising the stakes, right? It's like,
we'll take your word.
Let's do it. It's on. It's on. All right.
Take the risk.
Oh, well, yeah. Well, if you make a mistake, it's even. No. So these are vector valued functions. These are vector valued functions. So they map. Here's a funny word, map. So what does that mean, map? Send. That's what the word people use in math. They map real numbers. So they take real numbers to vectors. So that's a word that people often use in math. So if you have like a function like, f of x equals x squared, this maps a real number x to a real number x squared, right? It takes x, and look at this notation, and sends it to x squared. Ever seen that before? It's pretty hardcore. I've never done that in class, but now first time. So it takes x and sends it to x squared. So it maps a real number to a real number, which we call x squared. This takes t and maps it to a vector. Maps it to a vector. Let me give you the idea behind it. Here's a pick. And I'm just going to draw the pick for 2 dimensions because it's easier to draw. It's kind of an interesting concept. So here's the y-axis. Here's the x-axis. And so the graph of a vector valued function can be thought of as the collection of endpoints of the vectors. You say, what? Yeah, like this. So say this is a graph. So maybe here, this is r of t sub 1. I know it's really hard to read. R of t sub 1. So the vector ends there. And then maybe here, this is r of t sub 2. So the vector ends there. And maybe here, this is r of t sub 3. So the vector ends there. So it's basically, if you have a bunch of vectors, it's like vector, 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 vector. It's the collection of terminal points that you see on the graph. Okay? It's the collection. So the endpoint of the vector is what you plot. So if you have a bunch of vectors, the endpoints of those vectors give you a graph. A classic example, which I wasn't going to do because it's not in my notes, but here's a simple one. It's probably one of the most important vector valued functions. Why not? Let's deviate, learn some stuff. I'm going to write it in component form to be different. So it's angle bracket cosine t, sine t. Okay? And here, t is in 0 to pi. This is a famous example. Does anyone actually know what the graph of this vector valued function will be? Anyone actually know what it would be? A circle. Very good, Luigi. Yeah, this is the unit circle. This is the unit circle. We'll be practicing stuff like this later. But basically, this is your x on the unit circle. The x coordinate is cosine, and the y-coordinate is sine. So basically you get the unit circle, right? So this is the unit circle. So it's a vector every time though. So what happens is you get the endpoints of the vector, and the endpoints of the vector are points on the unit circle, right? They're points on the unit circle. If you remember from Calc 2, you could call this x, and you could call this y. And you have these equations, and t is called a parameter. What types of equations are these from Calc 2? Do you remember? Parametric equations. Yeah, so basically we're doing parametric equations again, right? That's all we're doing, except we're going to do it in 3 dimensions as well in the sections that come, right? We're going to be looking at some 3-dimensional vectors, and we're going to giving them physical meaning and stuff like that. So there's some really cool concepts. A lot of physics stuff too. So parametric equations are the same thing, can be thought of as a vector valued function, right? So it's the same thing. It's the same thing. Same thing. A couple remarks. So first remark. Remarks. Marker's dying. So remarks. The first remark is that different functions can give you the same graph. Just like there's infinitely many parametric equations for the circle, there's infinitely many vector valued functions. So different functions can give the same graph. Can give the same graph. This marker's already dying. I don't know. Can you see the marker okay? Yeah, it just bothers me. I think it's just me. So different functions can give the same graph. The same graph. A really important example that maybe you didn't know, and I'll kind of squeeze it in here, just to coincide with this. If I change it to a different vector valued function, say we use cosine 2t, sine 2t, and then say we change the interval to keep the interval the same, what happens is this time the circle is traced out twice. If I change the interval to 0 pi, then it's traced out twice as fast. Well, actually, yeah, a little bit faster. So when you do that, it just changes the speed. Changes the speed. Changes the speed. So yeah, so I'll leave that out. But 2t makes it twice as fast, 3t 3 times as fast, 4t, but it gives you the unit circle. It gives you the unit circle as well. So there's infinitely many parametric equations, right? Infinitely many. No, that's it. That's the only remark. 2. Well, why not 2? 2. The domain of R. I don't think this is going to come up, but the domain of R is the intersection of the domain of the components, of the domains of the components. Domains of the components. In other words, the component functions. So everything has to make sense. That should make sense that it's the intersection. Intersection is closely associated with the word and. I'm sure you remember and means intersection in math. They always say that. So why is that important? The domain is the set of all t's the set of all t's that you can plug in that makes sense. What does it mean for this to make sense? It means that this has to make sense and this has to make sense. That's where the intersection comes from, because this has to make sense and this has to make sense and this has to make sense. So you take the intersection of all sets where everything makes sense. We'll do some examples from the homework today. Let's do an actual example now of sketching a vector valued function by hand and finding the orientation by hand. I'm pretty sure that on your test, I'm not going to ask you to sketch anything. I don't think I usually do, so no worries. Except I had a better marker. I got a new one right before class somewhere. I'll just have to use this one. It'll have to do. So there's a bunch of them over there, but I don't think any of them are very good. So, all right. I miss chalkboards. Did you all have chalkboards in other schools?
I never went to school.
You never went to school? No, it's okay. No, sorry. Hey, some people don't go to school, right? I didn't go to school for that long. Never mind. Yeah, I didn't go to school for a long. I went to college. My notes say do this one, so I should do it. So sketch. So sketch. We have r of t, and it's 2 cosine t. 2 cosine t. I'm going to put it in parentheses. I hat minus 3 sine t j hat. And then here t is going to be between 0 and 2 pi. And we're going to sketch this, and we'll just look at it. We'll also talk about the orientation as well in this example. Yes, that's it. There it is. That's what it's all about. Look at that. Oh, I'm going to treasure this marker. See the difference? You can tell the difference, right? Much better. So in order to sketch this, what you want to do is you want to call this x, and you want to call this y. So you can think of it in component form if you like. So 2 cosine t, that might make it easier. And then negative 3 sine t. Okay, think of it like this. All right, so we'll call this x. So x is 2 cosine t, and then y is negative 3 sine t. It's just a clever trick to sketch this. It's a good way to do it. Right, so you take your vector valued function, you call this x, you call this y. And then the trick is to use some trig identities. So whenever you have trig functions and you're trying to convert this to like a rectangular equation, solve for the trig functions. So divide by 2 here and divide by negative 3 here. So we would have x over 2 is cosine t. And then here we would have y over negative 3 is sine t. So again, whenever you have a vector valued function and you're trying to write it like in a rectangular equation, which comes up, I think in the homework you have to go backwards. You're given the equation and you have to write it as a function. It's a little bit harder. We'll practice that today. So do this. And now you just write down a famous identity from math. Right? If you know something from trig, cosine squared plus sine squared. Anyone remember what that's equal to? 1. Yeah, 1. So 1. So 1. So write that down. This will be useful on the test. Why? Because we're going to go backwards. Again, that's later. We'll do a bunch of these too. So we do that, and then now just plug in. Now just plug in your cosine t. So cosine t is x over 2. So it'll be x squared over 4. It's a beautiful problem. Plus. This is nice because when you square the negative, it goes away, right? So you get y squared over 9, and that's equal to 1. So this is the rectangular equation. This is called a rectangular equation because it's in rectangular coordinates. It's in x and y coordinates. And anyone know what the graph of this is? Huh? Nope, close. No, it's not a hyperbola. It's an ellipse because it has a plus sign. If it has a minus, it's a hyperbola. We're gonna practice more of these later. Don't worry. There's a bunch on the worksheet, so we're gonna do a bunch of them in class. So it's an ellipse because you have a plus and they're both squared. If only one of them is squared, it's a parabola. So just really quick for fun, just fun. Let's have some fun. So like if you have something like this would be a parabola. I just wanted to say it that way. No, parabola. My college algebra teacher used to say that, parabola! Like nightmares. It was really hard. X squared plus 4. It's really tall. And then this is, we said this is an ellipse. This is an ellipse. And then something like this. What would that be? A circle! Yeah! Round and round we go. Ooh! What if we do this? What if we put this symbol here? What's that? That's a hyperbola. Or hyperbola. Yeah, hyperbola. Like a disease. Yeah. No. Hyperbola. Hyperbola. Ebola, I think, is the disease, not right. I know. I think about diseases a lot lately because of the corona thing.
Well, yeah, I was about to say you have the wrong decade.
Yeah, right. It's the wrong decade. Was it this class that was talking about the coronavirus, or was that my DE?
No,
yeah, my DE class. I know. I Googled it. I spent time reading about it. I was going to look at a DE to help model it. Like, not that I could figure it out, but like, you can model the spread of the virus with the differential equation. Yeah, from you. Because of you, I was looking it up this weekend. I was looking it up on my phone, and I Googled DE coronavirus and. Yeah. I think you can model it, somewhat.
This guy's on crack. No, he's busy Googling.
Yeah, DE coronavirus. Yeah, I know. If the government's watching me, I'm done. Yeah. All right, so let's graph this. So in an ellipse, this is really key. So in an ellipse, A is always the square root of the bigger number. Okay, that's really important. So A is the square root of 9. And B is the square root of 4. No worries. I'm not going to put any graphs on the test. I don't think I will. I won't. How about just say I won't?
Yes, thank you.
So now I can't take it back. So there will not be any graphing on the test. Huh? Oh, God. Yeah. Okay. Yeah, it is. Yeah. Yeah. Okay. So in an ellipse, A is the square root of the bigger number. Okay. So because the bigger number, oh, the center is 0, 0, right? Because there's no numbers there next to the x or the y. So the center is 0, 0. And because the bigger number is under the y, the major axis is vertical. That means that from the center, we go up and down by A. If the bigger number was under the x, then the major axis would be horizontal. That means you would go left and right by A. So I know it's a lot of information, but it is. In pre-calc, this is like one of the hardest topics. So because the bigger number is under the y, we go up and down by A. It's a cheap way to do it. If the bigger number is under the x, we go left and right by A. A really cheap way to do it, and I do not recommend doing it this way. I shouldn't even say it, but I'll say it. It's too late. Square root of 4 is 2. It's under the x, so you go left and right by 2. Square root of 9 is 3. It's under the y, so you go up and down by 3. I think that always works, but it should. It's just sketchy. Like it lets so many things not work. Like when you're trying to find the foci and stuff, it won't help you for that. But we don't need that, so it doesn't matter. The foci? Is it foci or foci?
I believe it's foci.
Oh, is it really? I thought it was foci, but I had a student once who would say foci. I was like, whoa.
I wonder if it's just one of those things you like just do whatever you want.
Yeah, tomato, tomato. Yeah. Mm-hmm. Either. That's the ellipse. To find the orientation, the cheap way to do it is to type it in your calculator, put it in parametric mode, graph these bad boys as parametric equations, and change your step to like 0.01 and hit graph. And it'll just go and it'll graph really slowly, and you'll be able to find the orientation. The way to do it by hand is the way we're going to do it now. It's grind it out. To do it by hand, to find the orientation, I'll write it down. I'm going to write the step down. And again, you will not have to graph on the test. So this is just like because you're supposed to learn stuff. So to find orientation, plot, right, plot points in increasing values of t. So I'll show you how to do that. So I teach this in Calc 2 when I haven't taught Calc 2 in years. In Calc 2, usually I give them 4 of these on their test, or like 2 to 4, and they have to graph all 4. That's why in this class I'm like, I don't really want to make you graph this in this class. You've already passed Calc 2, right? You're here, so I can live with myself. So this is t, x, y. So we need nice numbers. How about 0? 0 is a really nice number. 0 is like the nicest number in the world. 0. Oh. So let's see. We're plugging them in here or in here. It doesn't really matter. I'll use this. So 2 cosine 0. Cosine 0 is 1. Uno. So it's 2 times 1. So it's 2. Boom. And then sine of 0 is 0. 0. Let's try pi over 2 now, because that's easy. Yeah, like pi over 6. No, I'm kidding. No, pi over 2. Like pick like a hard angle. 5 pi over 7. Use an identity. Cosine of pi over 2 is 0, right? 0. So it's going to be 0. Sine of pi over 2 was 1. So this is going to be negative 3. Negative 3. Going slow. We got time. We're going to do a lot of examples today. I think last time I taught this section, I didn't do enough problems from the worksheet, and some people left and they didn't stay for the worksheet. And then on the test, there's problems from the worksheet. So, and they're harder. Pi is a nice number. So cosine pi is negative 1, so it'll be negative 2. Negative 2. This is fun. I haven't done this in a while. It's kind of exciting. Sine of pi, what would that be? 0! Yeah, the whole thing is going to be 0. So let's look at our graph here. So let's see. So first we're here. Then we're at 0, negative 3. So x is 0, y, so then we're here, right? Is that right? So going this way. And then we're at negative 2, so then we're here. So it looks like that. That's the orientation. So it goes in a circle like that. A circle like that. Yeah, I thought it was going to go the other way too. I think because the negative sign, maybe. Yeah, I was like, is that wrong? Like when I wrote it down, I'm like, oh, like yeah, because I haven't done any of these problems since last year. So.
No, sorry.
Yeah, you sure? Okay. This one says skip, so I'm going to skip it. My notes say do homework. So let's do a homework problem. So my notes just tell me what to do. Like, all right, I think I know what I need to do. Like, yeah, a problem like number 1. Let's do number 1 from the homework really quick.
So that's a clockwise orientation?
Yeah, that's the way a clock moves, right? Yeah, so clockwise. Yeah, I was thinking about the clock. Yeah, yes. That's clockwise. Yeah, I should write that down. Clockwise. Good. Good hit out of the. Let's do number 1 really quick, just for fun. These are multiple choice in the homework. You have 30 tries, and there's 4 choices.
There's pretty much no way you can screw it up.
There's no way you can mess it up, right? So I'm just going to do one just to, because this one's a little bit different, so I feel like I should do it. Yeah, so there's no way you can mess it up. Good, Michael, right?
Yeah.
Yeah. T over 3 I hat. The homework is very varied. Like there's all kinds of like problems with limits and stuff. The next set, stuff comes out of every. It's not hard. It's just a lot of random questions. Like they just expect you to like learn everything really quickly. Like you should know how to find the derivative, limit, integral. That's what we're doing today of all of this. So the question is to sketch and indicate the orientation. So sketch. So I guess you could just plug in values of t, like plug in t equals 0, t equals 1. I mean, you could do that. You could write it in rectangular form first. I kind of like doing that, writing it in rectangular form. It just makes me feel better. Let's do that first. So as before, we'll call this x. And then we'll call this y. And then in this case, whenever it's trig functions, you solve for the trig functions and you use an identity. Whenever it's something like this, I guess you could just solve this for t and plug it in here. So to solve this for t, we could multiply by 3. Yeah, so we do 3 here, we do 3 here. So we get t equals 3x. Yeah, it's beautiful. So we end up with y equals 3x minus 1. So that's the rectangular equation because it's written with x and y. So now you know, like you can do like a rough graph, right? Just a rough graph. So like when you plug in 0, you get -1, so you're here. And the slope is positive, so yeah, it's a terrible graph, but it looks something like that. Notice I didn't do this because you can't, right? Because there's an orientation. So, yeah, and plus I don't want to lose points. So it looks like that. So now we just have to pick some points and plug them in to figure out the orientation. I think 0 is a good number because we already know what that's going to be. Plugging in 0 for t, it's up here. The x equals t over 3. I know you can't see it. Here, this one and this one. So plugging in 0 here, we get x equals 0. And y equals -1. Right, -1. So we're here. So this is our first point. We just need one more point. How about we plug in 3? Why 3? Because it's t over 3. I want to make it easy. So plug in 3, you get x equals 1. And what would y be in this case? 2. Good, you're still with me. 2. So you know what's going on. Plugging it in here, right? Putting the t's in here. So I put a 3 here. 3 over 3 is 1. 3 minus 1 is 2. Okay, so we're here. So that's the orientation. That's it. So that's it. Any questions on this one, on these? Pretty easy, right? Now it's going to get hard. Okay, it's going to get hard next. Let's do number, well, not yet. Let's do number 3 from the homework. Number 3. So number 3 is something you will have on your test. Okay, it'll be one of the topics, and you'll have a bunch of these. Okay, so number 3. By the way, did it help when I gave those review questions? Were they helpful? Like, yeah. I'll do that again for every test. So yeah, it seems to work. People do really well. So it's especially beneficial for these sections because there's so many weird questions in the homework. So like it lets you like know what to focus on. Oh, there's nothing in my notes. No, I'm looking at them. So we have this.
So we're not going to graph it in the test.
We're doing this instead on the test.
Okay, so we're not going to do this.
No, we're not going to do any graphing on the test. But this you will have to do in the test. So the question will say, good question. Yeah, so no graphing on the test. That was just because it's in the homework and you're supposed to learn stuff. So write as a vector valued function. So write as a vector valued function. I'm going to do a couple of these. I want to do some from the homework, and then I'm going to do some from the worksheet as well. So this is actually a really easy one. It's so easy it hurts. So solution. So the goal is we have to, yeah, like my arm hurts now. No, I'm kidding. So the final answer is we have to write it like this. So we have to parameterize this. We have a line. This is kind of an interesting idea. We have a line, and we have to express it in terms of parametric equations. And then we have to express it as a vector valued function. So the idea of taking a graph and parameterizing it is really important in mathematics. It's actually really easy. So you can just let x equal t. You could just do that. Right? Why not? Right? Let x be t. And then in this case, y would be t plus 2. So these parametric equations will give you this line. So as time passes, for a given value of t, you get a point on the line from these equations, right? So you just call this t, plug it in here, you get that. So that's pretty cool. So now we've just taken a line and we've parameterized it. But the question, well, is the calculus 3 question, right? Because this is calc 3. So because of that, we have to make this extra step. So we have to write our answer as follows. So it'll be t, the x component, I hat, plus, and then the y component, so t plus 2 j hat. And that's it. That's it. That was ridiculously easy, but still important, because maybe you wouldn't know how to do it, right? So it's really easy. So whenever you can do something like this, you just do it, right? I mean, why not? There's infinitely many ways to do it. This is just one way. So given a line, you can parameterize it just by replacing x with t. The hard ones are the ones with trig functions, which we'll do shortly. Yes?
So all we do is replace x with t for a line?
That's it. Just replace x with t, rename y, and plug it in here. So x and y. That's it. Yeah. Super easy, right?
My arm hurts now.
From it's just so easy it hurts. Oh, it's so good. So good. Number 4 is the same, so maybe I'll leave it to you. 5 is harder, so 5 is test level. I mean, so is that. I mean, I could put that on there. Do you want that on your test? Yeah. You do? I will try to remember. Okay, don't get it wrong. Okay, so. I mean, hey, if you get it wrong, don't worry. I mean, it happens. Right? I don't judge, by the way. Like I'm used to. I've had people take tests and miss like every question. I'm like, I've seen it all. Like, not all, but a lot. Same question. Want to write as a vector valued function. So here's where you have to know some stuff. So first of all, this is a circle of radius what? 3. So we know, we talked about this before, we talked about the fact that cosine t and sine t parameterize the unit circle. So whenever you're trying to parameterize a circle of radius r, you can use these. This will always, this is double points, right? Whew. I need more soda. This will always, I mean, this is such useful math. Whenever you're trying to parameterize a circle, this will always give you, this is for a circle, always. So in this case, what's our r going to be in this case? 3. 3, yeah. And you can check. Let's check. Because see, look. If you let x equal 3 cosine t and y equal 3 sine t, you can check. Let's check. Let let's check. You don't have to check on the test. I'll believe you, right? Just get it right. But let's check. So just replace it. So it'll be 3 cosine t. This is useful math. I mean, sure, it's Calc 3, but like this is like stuff that you use a lot in other math. I didn't learn this in Calc 3. No way. Plus 3 sine t equals 9. I learned this in complex analysis. Yeah, like 4,000 level, like beyond this, because it's useful. And then this is 9, so this is 9 cosine squared t plus 9 sine squared t. You learn how to parameterize a lot of things in that class, because you have all kinds of graphs, and you have to integrate over like circles and parabolas and ellipses. Oh, I see, said the blind man. What can you pull out here? A 9. So you get 9, and then you have cosine squared plus sine squared t. So you see 9 times 1 is 9, so it checks. So it does check. So you can skip all of this, right? But it's good to see it. It's good to see it. It's really useful math. So now we can just write the final answer down. Because this is the Calc 3 class, we do have to write it this way, right? We have to write it as a vector valued function. I keep saying that because you use this in other classes too. You know what? Let's use component form, because we can, right? I mean, it's right. So angle bracket 3 cosine t, 3 sine t. That's it. I like this. This is like the fun math, at least for me. It's good. It's good. Good stuff. I know. That's good. Yeah, it's good. The Diet Coke is life. They say it's really bad for you. Any questions on this one? By the way, you could put the sine t here first. It's still right. It doesn't matter. You can flip it. You can put the sine t in. It'll still work, right? It'll still work. You can also put a negative sign here. It'll still work. Because you squared. You can do negative 3 cosine 4t. You could do that. No. But then you have to have a 4 here. The numbers have to match. So if that's a 4t, that has to be a 4t. Hey, what's up? All right. Any questions on this one? You want to do a harder one? Let's do it. Let's do it. Oh, yeah. Here, so I'm going to make this one up. This is similar to what's on the worksheet. So this is not in the homework. This is harder than what's in the homework. So same question. Write as a vector. Let's do a couple. Valued function. I think this is probably one of the trickiest things we're doing today. I mean, it's supposed to be pretty tough. So A. Oh, let's go nuts. Let's go nuts. No, wait. Yeah, we got this. We got this, right? I believe in you. X plus 1 squared plus y minus, what's an uncomfortable number? 27. 27. Equals 16. Let's go back down to Earth.
Because radiuses are annoying.
Huh?
The fact that you have to square root every radius is annoying.
Mm-hmm. I could have put a 10 here. We could have still handled it, but erase the 1, make it a 6. No. Let's just leave it at 16. All right. So here's where you have to use some thinking. We need to plot something here that will work. Okay. So this squared plus this squared needs to be equal to 16. So obviously the circle. Well, what's the radius of the circle? 4. So what you want to do is you want to think, what can I put here and what can I put here? So whatever you put here, well, here, this whole thing should be 4 cosine t. Let's think about that for a moment. So if this was 4 cosine t, and if this was 4 sine t, do you see what would happen? You would square this. You would get 16 cosine squared. You would square this. You would get 16 sine squared. And then what would you do with the 16? Pull it out. So do you all see that if this was this, it would work? Everyone see that? So if this was this, if these match, it'll work. So if you make this 4 cosine t, and if you make this 4 sine t, you can do it, right? Let's go ahead and write that down. So 4 cosine t is going to be x plus 1. And then 4 sine t is going to be y minus 27. So again, the thought process is that you want to get 16. So you know you have to have a 4. So, and you know you have to have a cosine and a sine because it's a circle, right? So you call this 4 cosine t, and you can check. We can check. Do you want to check it just to convince yourself that it works? No, you don't want to? Okay. Yes. Yes. Okay. Let's check. I'll even spell it out. Let us check. Let us check. Sounds very primitive. I don't know. Let us check. So if we're checking, let's prove it. Let's actually write this down. X plus 1 squared plus y minus 27 squared. This is equal to. Let's actually just like show it's true. So we said that x plus 1 was 4 cosine t. So all we have to do now is replace it with 4 cosine t. And then we said that y minus 27 is 4 sine t. So replace that with 4 sine t. Now you see the same thing happens, right? This is 16 cosine squared t plus 16 sine squared t, which is 16. I can factor it out. I'll skip that step 1, which is equal to 16, so it checks, right? You pull out the 16, you get cosine squared plus sine squared, so you get 1. Checks. So sometimes people have a really hard time with this. I don't know of another way to like explain it. I think this might be the easiest way. I don't know. For me, at least, it works if I think of it this way. So this squared plus this squared has to be 16. So you know that this has to be 4 cosine t, because when you square it, you get to 6. Does it make sense? It's pretty hardcore. It's pretty hardcore stuff. So now we're done, right? We just got to solve this for x. So x is 4 cosine t minus 1. Y is 4 sine t plus 27. So these are the parametric equations for the circle. Right? There's a formula for it too. I think you could come up with a formula for it. You could. So now you just write it. Oh, what's left to do? What do we have to write it as now? As a what? Vector valued function. Yeah, because it's Calc 3. I always think, oh, it's Calc 3. Wait a minute. Like, so normally we'd stop here. Like if we were parameterizing a circle, that's what we just did. Be like, okay, we're done. But no, it's a Calc 3 class, so we have to actually write it. I'm gonna go component form because I love components. I don't like the I hat and the J hat and the K hat. They're just, I don't know. Looks clean. Yeah.
How is it minus 1 plus 27? Like, where do you get those?
Oh, thank you, Udash. So basically, I solved this for x. So I subtracted 1. Thank you. No ask. It's good. And then here, we added 27. Good, Udash. Very good. Excellent question. Good. This is harder than I think this is harder than anything that's in the book, maybe. Even in, like, if you look in the book, there's nothing that's this. But I thought, you know what? It's an opportunity to show you some useful math. So we should take it, right? Because, you know, this is the only time in your life you're taking Calc 3. So let's do something even more interesting. One more. Check this out. B. How about this one? X squared over 9 plus y squared over 4 equals 1. Oh wow, my notes are almost done. Like we're almost done with this section. After this we're almost done. Like one example and we're done. Any ideas? Any ideas for what we can pick for x and y? So what do you think x should be? Cosine, so cosine, but what number times cosine? 3 cosine t. Very good. And what do you think y should be? 2 sine t. You see, because you want them to cancel, right? Because this is going to be an ellipse. So now you see, we've just parameterized an ellipse in 15 seconds, right? Using our minds, right? Because you know you want it to cancel. So just really useful mathematics, right? Really useful. We're done, right? And you can check, right? You plug it in, you'll get 9 cosine squared. The 9s will cancel. Plug it in here, you'll get 4 sine squared. Do you want to check or do you see it? Everyone see it? Do you want to check? Oh, you're nodding. No, you do see it? Really? Okay, all right. So the answer, I believe you. I think you got it. So the answer here would be angle bracket 3 cosine t, 2 sine t. You know what I'm going to check? I'm going to show you just anyways, just in case there's someone out there in the class that doesn't get it and they're like, oh, I don't get it. This is horrible. Let me just show you. I don't want to lose points. I haven't messed up today, have I? So let's check. Like I won't. I usually don't mess up in Calc 3 after the first test. You know, the first test is the hardest, like I said. So after the first test, I stop making mistakes. So I won't mess up. This is 9, right? 9 cosine squared. So these are going to cancel. So we're just going to get cosine squared. These are going to cancel. So we're just going to get sine squared. That's a plus. So we just get 1. Boom. There it is. There it is. That's it. Any questions on this one? Questions? Want to do a harder one? Let's do a harder one. Okay. Do you all think this is hard? Like, does it seem hard to you? No? It was supposed to be. Okay. All right. Just wait. Just wait. Just wait. This is supposed to be hard. Here. How about this? Okay. All right. It's on. Here. X squared over 4. Here. Try this one on your own. Take 2 minutes. Just 2 minutes. See if you can do it. I don't think anyone will be able to do it, but try it. Just so you see it's hard, right? Like, I want you to realize how hard this is. Because if I show you, it's easy. So take 2 minutes, work together, make friends. See if you can do it. I don't think anyone will get it. I mean, this is like, yeah, it's got a negative. I mean, I don't expect you to get it, but it's okay. Take 2. See. No, we didn't do this one. This is different. You can't use this identity anymore. You got to use something else. There's 2 ways to do it. Yeah, there's 2 ways to do it. Oh, Luigi has an idea. Oh, man, I'm hungry. These apples they're not washed, so that's all right. Should have washed them. Did you bring lunch? Bring your. No, you should eat. No, eat. It's okay. It's all right. I had tuna fish sandwiches, but I ate them earlier. I had 3. Yeah. See, it's hard. It's tough.
I'm done.
You're done? Really? Oh, I'm going to come look. Oh, Luigi. Yeah, so good. Let's see. That's one way to do it. All right, let's do it Luigi's way first. So, why was there an echo over there? That's weird. All right, so solution 1. Solution 1 requires that you know that 1 plus tangent squared is secant squared. I know. I don't do it this way. This is the Luigi method. So this is Luigi's way.
Yeah.
I know I misspelled your name, Luigi. I'm sorry. That's not how you spell Luigi's name. It has a D in it. So you can subtract. So you get secant squared x minus tan squared x equals 1, right? So you would let x equal, what would x be in this case? 2 secant. 2 secant. And then y would be 3 tangent. Yes, very good. So x is 2 secant, y is 3 tangent. So r of t, this is not what I was thinking of doing, by the way. I'm going to show you my way. You probably like Luigi's way better. That's okay. Nice work, Luigi. It's pretty impressive. Huh?
My trick is not upstairs.
Yeah. Well, the other way is a different way. So the other way I like because of the name. What type of graph is this? What is this? This is the what? It's a hyperbola.
Oh, wait, are you using hyperbolic?
That's right. It's on, right? So check it out. So my way, or the other way, I don't want to call it my way.
The only way that hyperbolic functions can exist with respect to, oh wait, isn't it ellipse? Oh no, it is based on hyperbola, right?
It is.
It
It is, yeah, hyperbolic. So the identity is cosine squared, t, minus sinh squared t is equal to 1. Right? So that's the other way. Yeah, I know, it's beautiful. Right? The hyperbolic functions will parameterize a hyperbola. That's what they're called, hyperbolic functions. So it's beautiful. So it's like really good mathematics. This is like learning.
This is learning.
Yeah, this is like really good math. Not just like, oh, let's do a problem. Like, no, this is real. So that's your x, and that's your y. So the hyperbolic functions parameterize a hyperbola. I mean, I think that's why they're called hyperbolic functions. I don't know, but it makes sense, right? So then that would be it. You just use this 2 cosine t 3 sinh t. Sinh t. So I figured it would just be a good opportunity to show you all this. You'll have some of these on your test. I think they're good. It's like good math to like learn and know how to do. Yeah?
Is it cool if we solve it the other way? Because like, that's how I solve
You like this? Oh, you were able to do it also?
Yeah.
Woo!
I'm down, not those.
Oh, it's okay. No, that's good. That's good. That's good. That's good. No, it's really good.
It would still be more interactive.
Yeah, yeah. Mm-hmm. Yeah. Mm-hmm. Yeah, Luigi's way works. Yeah. All right. What else is in the homework? So there's a couple of the homework problems, like where you have to find a limit. Like let's do number 7 from the homework. Let's do that one. So let me just say this in words instead of writing it down. To find the limit of a vector valued function, you just take the limit of each piece. To find the derivative, which is the next section, you take the derivative of each piece. To integrate, you just integrate each piece. So it's just like regular calculus. It's just like Calc 1. So we have limit. This is a really easy problem. T goes to 0, I believe. Anyone have it?
It was pi.
Pi? Oh, it's pi. Oh, it's pi. It's pi. Thank
I
you.
don't know if that's point or not.
Is it? No, it's 0. It's 0. It's 0. It's 0.
That's 2 points for 6, I'm sorry.
It's okay. That was it.
T to 3t. Pi.
Where's the pi? Oh, I?
Oh, sorry.
Like that?
Sine AT.
Plus or minus or
Oh, sorry, plus.
plus sine.
I'm gonna let someone else do it.
No, come on, Rush, it's good. Sine AT
Over AT. Plus J.
J hat. Yeah, it's good, it's good. No, it's good, it's important, it's good. Plus
B to the negative 8t. K hat.
negative 8t.
Yes.
K hat like this. That's it. Okay. Nice problem. Really easy. Really easy problems. You have to find the limit. I think this is the hardest one in the homework. There's another one that's even easier. So these are nice sections. So we're doing 3 today. We're doing 3 sections today. So you just take the limit of each piece. Take the limit of this, limit of this, and limit of this. Now, this limit is 1. This is a limit from Calc 1. So if you have the limit as x goes to 0 of sine x over x, I wish I was a little bit taller, you get that. Remember that? No, it's not squeeze theorem. It's just it's a formula. You can also use L'Hopital's, right? Because it's 0 over 0. So you could take the derivative. But it's from Calc 1. I teach Calc 1, so I'm like really aware of the formula. Whenever you have a limit like this, where these match, and this quantity is going to 0, you just get 1. Okay. So let's go ahead and write the answer down. So this will be e to the 0. So I'll show the work. E to the 0 times I hat plus 1 times j hat plus e to the 0 times k hat. I'm showing extra steps. E-OK. That's like an alien. It's an animal. E-O-I. E to the O, e to the 0 is 1. So this is I hat plus j hat plus k hat. I wanted to add an L, but there's no L. Think about, A, B, C, D, E, F, G, H, I, J, K. They're in order.
Yeah.
L, M, N, O, P, but there's no.
Unless you were like went out to 7 dimensions or something ridiculous and then maybe you could do it.
Mm-hmm. Yeah, you could. Yeah. Yes, I get it. Yeah, you could. Everyone okay with this one? Any questions? Does everyone want to see what we did? We just plugged in the 0 here. This limit is 1. And then this is 1 as well. There's not that many examples in the homework, so don't expect anything bizarre that you haven't seen in the homework, right? It'll be just like last time. Let's do number 8. Let's do number 8. Number 8's a different question. Something smells really good. Number 8. Oh, number 8. That's good. So R of t is equal to, so we have 1 over 3t plus 1 I hat plus, oh, he's gone. Is it 1 over t j hat, the next part? It is? It is? 1 over t J hat? Okay. And what's the question say?
Determine the interval on which the vector value function is continuous.
It's continuous. Okay. So we want to know the interval where it's continuous. Thank you. Thank you, Luigi. So interval. Okay, interval where it's continuous. So basically, these are both rational functions. That means they're fractions. So they're going to be continuous wherever they're defined. So you just have to think about where they're both defined. So this is continuous everywhere except when the bottom is 0. What's going to make the bottom 0 in this case? Negative 1/3. Everyone see why it's negative 1/3? Because you could do this, and then subtract 1, and then divide by 3. So this is a problem. So this is a problem point for there. And then what number is a problem here? 0. So 0 is the problem here. So the function is continuous everywhere except at these values of t. So what we have to do now is write down the answer. The question wants the intervals. So it's everything except these. If you remember in math, when you're doing that, you can draw a line interval like this, and then you can plot this, and you can plot this. Remember this? And then to get rid of numbers, you put those opposing parentheses like this. And then it's everything except these numbers.
What about the negative 1?
What negative 1?
3t equals negative 1.
No, I solved for t.
Oh.
Yep. So it's everywhere. It's okay. Good. Ask. It's your life. No, it's so it's everything. No, it is. It's everything except these. Yeah, you got to make it count. Right? This is the only time you'll be in this class in Calc 3, right? So I mean, this is it. So it's everything except these. So now we can write the answer down in interval notation. I don't know if you remember how to do that. Where would you start? If you're going from all the way over here, what would it be? To negative. And what do you put to connect the sets? Do you remember? Union. Good. Negative 1/3 to 0. And then what goes here? Union. 0 to infinity. Yeah, it's been a while, right? So it's good to review. I feel like it's better we do these than just not do them. So just a little bit of review from the past. This is the only one like that in the homework. It's a really scattered homework, right? We had a graph of a vector valued function. We have a limit. We have a problem like this. It's not hard. It's just a lot of different stuff. So let's see what the next one is. I probably should do number 9 for you. Let's help you. Yeah, I should do it. I should do it. Let's do it. Any questions on this one? All right, let's do number 9. Number 9. Yeah, number 9. So it's r of t. I already forgot what it was. Is it square root? Anyone have it?
Square root t.
T? T? Just t?
Yeah.
Uh-huh. T minus 2. J hat? It's got a k hat? Hey, what's up? So it's I hat and k hat? Really? Oh my god, that's so weird. Okay. So the j hat's missing. It's in the middle. It's 0 j. Hey, Duncan! What's up? All right. Oh, that's so weird. Why would they do that? It's not going to make a difference. So, okay. So the question is the same. It's to find the intervals where the function is continuous. So intervals where continuous. This is the last homework question. We've like completely covered this section after this. We've overdid it because we did extra problems, like overkill, like just ridiculous. So the reason I wanted to do this one is because you probably don't remember how to do it. So we're looking for we're looking for where it's defined, right? That's what's going to be continuous. So the square root is defined whatever's under the root is not negative. So that means whatever is under the root is positive or 0. So basically this has to be greater than or equal to 0. And this has to be greater than or equal to 0. So whenever you have roots and you're looking for the domain, you take whatever's in the square root and you set it greater than or equal to 0. It's been a long time since you've done that probably. Why? You can't take the square root of a negative number because you'll get a complex number. This is Calc 3. We deal with only real numbers. So this can't be negative, so it must be 0 or positive. In other words, it must be greater than or equal to 0. Likewise, this can't be negative, so it must be 0 or positive, so it must be greater than or equal to 0. The and comes into play because this has to make sense and this has to make sense. So you have t bigger than 0 and t bigger than 2. Two ways to proceed. Method 1, you can use your mind. So t is bigger than 0. I don't like doing this. I might mess up here, but I can say the wrong thing. So t is bigger than 0 and t is bigger than 2. So if t is bigger than 0, that doesn't mean it's bigger than 2. But if t is bigger than 2, that means it's bigger than 0. So t must be bigger than 2. Ouch. Okay, so t is bigger than 2. So the answer is that. Again. Okay. I'll say it again, then I'll show you the work. I know it's hard. Okay. So t is bigger than 0 and t is bigger than 2. If t is bigger than 0, it doesn't mean it's bigger than 2. But if t is bigger than 2, cheap trick that I teach in my college algebra class, always take the bigger number. Always works. The real way to do it, draw a number line, right? So boom. Oh, this brings me back. So here's 0, here's 2. This is the way like it's taught, right? So, oh, t bigger than 0. So you put a bracket and you shade that way. I used to have a guy in my class like, shade whichever way the arrow points. I don't like that at all, but it does work. You ever heard that? Shade whichever way the arrow points? Yeah, I don't like that. I can't live like that. It's and, so you take what they have in common. Maybe brings back some memories, right, of other math. Yep. So, multiple ways of doing it. Yeah, so that's that. Any questions on this section? That's the whole section.